Hello everyone, this is Karthik and today I'm going to give a presentation on security of Internet of Things, which is one of the trending technologies in the current scenarios. So coming to our agenda, we have the introduction part, the history of Internet of Things, how it is evolved and how does it get the name of Internet of Things and the reference models in it, the background and the score of applications, the vulnerabilities available in Internet of Things and the countermeasures which are needed and which should be implemented, and finally the emerging challenges and conclusion. So coming to the introduction part, we can see everything is connected to each other. So in order to describe the Internet of Things in one single word, it's like the connection of billions of devices together through using internet. So the word internet plays a crucial role in applying this Internet of Things. So what is Internet of Things? The Internet of Things refers to the billions of physical devices around the world that are now connected to the internet, which are all collective and sharing data. So connecting up all these different objects and adding sensors to them adds a level of digital intelligence to the devices that would be otherwise dumb, enabling them to communicate real-time data without involving a human being. So this is the main concept of Internet of Things. So here we can see the internet connected objects which are able to connect and exchange data, which describes Internet of Things. And now we can see in this slide that connecting everyday things to the internet and enabling them to collect and exchange data. So it is like a type of interrelating to each and every small thing. And why do we need IoT? So this IoT wants to connect all potential objects to interact each other on the internet to provide secure comfort for a human life. So this IoT makes the world possible to stay connected. Nowadays we almost have internet infrastructure wherever and we can use it whenever. So embedded computing devices would be exposed to internet influence like using MP3 players, traffic lights, microwave ovens, washing machines, dishwashers, etc. So this IoT tries to establish advanced connectivity with the help of internet among these mentioned devices or systems. So this IoT images all the things that are connected together and information would be interacted with each other over standard and different protocol domains and several applications. So coming to the benefits of IoT, we have efficient resources utilization, minimization of human effort and saves time. So the main thing what we need is to minimize the human effort. So we need the machine to do its thing what the human do all the time, so that we can save a lot of time, we can save a lot of resources, and also we do have different advantages like automation and control, saving the information, monitoring time to time, saving time and saving money, and also we have many other advantages through this Internet of Things. So coming to the history of Internet of Things, it was first came into act in the year 1982. A modified Coke machine at Carnegie Mellon University became the first connected smart appliance. So this IoT was first implemented by Kevin Ashton in 1999. The reason why it gets the name IoT is that although it's 16 the term IoT is 16 years old, but the actual idea of connected devices had been around longer, at least back in the 70s. So the idea was the embedded internet or pervasive computing, but the actual term Internet of Things was coined by Kevin Ashton in 1999 during his work at Procter and Gamble. Ashton usually works in supply chain optimization, wanted to attract senior management attraction to a new exciting technology called RFID, because the internet was the hottest trend in 1999, and it somehow made sense, and there you go, you get the name Internet of Things. So coming to the reference models in Internet of Things, we have several reference models like WSN wireless sensor networks and cloud services and several applications. These applications along with service composition, service management, object abstraction, and edge nodes. So these reference models are differentiated into three types of layers. One is user side layer, the other is service cloud side layer, and the other is edge side layer. So the edge side layer consists of edge nodes, communication, edge computing, whereas the service cloud side layer consists of data accumulation, data abstraction, and the user side layer consists of application, users, and centers. So these are the three main IoT reference models, as I already said in the last slide. One is wireless sensor networks, the other is cloud sensors, cloud servers, and the last one is applications. And coming to the Cisco 7 level reference models of IoT, we have these 7 levels of reference models. One is physical devices and controls, connectivity, edge computing, which plays a crucial role in this reference model, and data accumulation, data abstraction, application, and collaboration process. So coming to the edge devices, it contains things such as sensors, devices, and machines, and also RFID readers. And in the level 2, which is communication, this consists of the communication processing units, like communication between devices in the first level, communication between the components in the second level, and transmission of information between first and third levels. So in the edge computing, which is also called fog computing, is the third level of this reference model, where simple data processing is initiated. So this edge computing platform allows the application process by allowing small edge server between cloud and server in a location physically to the server. And in the level 4, which is data accumulation, it converts data in motion to data at rest and converts the network packets to database relation tables. So in the data abstraction, it combines the data from multiple sources. It gathers data from the multiple sources and put it in a single place. It uses simplifiers, filters, selects data to server client applications. And then in the level 6 and level 7, we can see application and users and centers, where I think we have a good idea in these two type of levels. So coming to the background, in this we discuss about the scope of IoT applications, the potential attacks and their motivation, the security requirements in the context of IoT. So in the scope of IoT, we have the smart homes and buildings, electronic health aids, smart vehicles, everything. Now everything is interrelated with the internet, and this provides an opportunity to combine sensing, communication, networking, authentication, identification, and computing. So these are the several type of IoT applications which are related to each and everything. And the next slide follows is a description of this slide of each and everything involved in the IoT applications. So the IoT application consists of the smart vehicles, the smart buildings, the health monitoring, energy management, construction management, environmental monitoring, production and assembly line management, and food supply chain. So coming to the potential attackers and their motivation, IoT based systems may manage huge amount of information and be used for service ranging from industrial management to health monitoring. So this IoT device consists of lots of confidentiality matter involved in it. So it has to be ready to face the potential attackers, and should be ready to give the counterattacks on those attackers. So The two things which most commonly used in the scope of IoT is the secure thing and the security attack, which is important to understand the characteristics which define security. And also the security requirements are broken into three categories as we know. One is confidentiality, the other is integrity, and the last one is availability, which is known as CIA triad. So these are the other things which are related with these counter attacks or potential attacks. These also for this confidentiality, integrity, and availability follows with accountability, auditability, trustworthiness, non-repetition, and privacy. So these are the vulnerabilities, I mean the possible ways that a device can be attacked or hacked. So coming to the edge side layer attacks, we can see hardware trojan, side channel attacks, denial of service attacks, node replication attacks, and corrupted nodes. So these are the several ways where a device can be hacked by the people externally. And also the through these RFID tags, tracking, inventorying, physical attacks, tag cloning, device attack, and eavesdropping. So the communication can be done through these things like eavesdropping, side channel attacks, device attacks, and injecting fraudulent packets, routing attacks. We can see, I mean, we are most familiar with these side channel attacks, device attacks, and injecting fraudulent packets. So if we take this injecting fraudulent packets, it usually takes the original packets out from the path and it adds a duplicate package which resembles the original ones. So the attackers might use this kind of attack to hack the particular device. And coming to the edge computing, it is a type of distributed computing which brings computation and data storage closer to the location where it is needed and also improves the response time to save the bandwidth. The way it originates of edge computing is lies in the content delivery networks which was created in late in 1990s to server web and video content from edge servers that were deployed close to the users. So we can see in this graph how this edge computing is centralized and decentralized from the time to time period. So in the time during 1970s we can see mainframe computing, and the next we can see micro and mini computing, and later in 2005 we can see cloud computing, and nowadays we have the latest fog or edge computing. So coming to the benefits of edge computing, we will get a faster response and the cost is manageable. I mean, it's not too bad to manage. So and also it's quite secure than other computing techniques. So so what are the day-to-day edge operational challenges that are faced by IoT? One is the temperature sensor data received on time. We have to check is IoT network overloaded or no data after rainy day, no network down, a sensor issue, traffic lights, camera not in sync. So in order to implement this IoT carefully, we have to check these things each and every time. I mean, almost each and every seconds, because we have to maintain the communication between these two things. For example, if we take the traffic lights and camera, if they are not in sync, then it could cause a lot of damage. I mean, it could also take several human lives, and it could also bring several human lives in danger. So we should make sure that these things are working fine and these are in a correct sync together. So what are the countermeasures we have to do if any IoT device is hacked or attacked? So is it necessary to give a countermeasure? Yes, it is. So we have to give a countermeasure if we are attacked, or if our data is stolen. So this is the summary of attacks and countermeasures, the ways how a device or node can be attacked. So the computing nodes, these are the RFID tags, the communication and edge computing. So in this column we can see the threats that are that can be done by the hackers against these type of things. These are the countermeasures where we can apply if we get these kind of threats. So I, I try to display these type of threads in a single box. So coming to the edge nodes, we have this type of threads like hardware trojans, denial of service attacks, side channel attacks, physical attacks, corruption node, and in the communication we get these, and in the edge computing we get these kind of attacks. So these are the some of countermeasure techniques as follows. One is the hardware trojans and a connected to node, which can be done in side channel signal analysis, and hardware trojans in trojan activation methods, and securing firmware update, DOS or conflag. So these are the several type of attacks that shown on IoT. So these are the top 5 attacks on IoT. One is Stuxnet, which is a malicious computer worm. It targets a SCADA system in nuclear planet in and the other one is Mirai botnet, which targets the routers and IP cameras. And if we just browse on internet, we can see a lot of attacks. I mean, the recent attacks that occurred on IoT. So these are the several reports which are stated by the cyber attacks on IoT devices at different times. So what are the emerging challenges for this IoT is that we have to increase the exponential part in number of weak lines and unexpected uses of data. We have to improve the privacy, and we have to take care of the physical safety and complexity and scale. So exponential increase in the number of weak links. So the majority IoT based devices rely on limited storage and computational devices, and also compact battery power devices. So this comes to the privacy, where you could be tracked or monitored by anyone as you're connected to the internet. So as you know, it's quite easy to be get monitored or tracked by any other one, and it may be done without your knowledge. I mean, we even don't know that we have been tracking by someone from most of the time. So the physical safety is the data breaches and the huge potential for many scenarios. Many new kinds of ransomware we haven't imagined that. So these hackers usually develop several kinds of ransomware from time to time, which cracks the privacy and security codes of several technologies. So we have to be ready to give a countermeasure to those things. And we can see every time the complexity and scale out of unexpected and emergent behavior. So coming to the conclusion, IoT is complex and poses some risk, though, but although it has several risks, I mean, we have several advantages through using this IoT, which can help innovate new process and initiatives that could transform businesses lives in the world. So thank you for listening my presentation, and if you have any queries, please do comment below so that I think I can solve your questions. Thank you very much.